This video will help solve section 5.6, question number 11. This question asks us to solve the right triangle with the given side and angle. We have alpha equals 11 degrees and C equals 24. And basically what solving the right triangle means is to find all angles and all sides of a right triangle. I find it helpful to draw myself a visual, so I've done that, and hopefully it will help you as well. And I've drawn a right triangle, and I've put in what we know. Alpha, the degree of alpha is 11 degrees. We know that C, or the hypotenuse, is 24. We know that this second angle is 90 degrees because it is a right triangle. And we're going to be looking for the beta angle and A and B sides. First we will find the beta angle, or find beta angle. And this is fairly simple for a few good reasons. First of all, we know that the sum of all angles of a triangle is 180 degrees. So I'm going to write 180. We know that a right triangle always has one 90-degree angle. So let's go ahead and subtract 180 minus 90, and that leaves us with 90 degrees. Now, the next thing we know is that if one angle equals 90 degrees, then the sum of the only two angles left must equal 90 degrees. Therefore, if we know one of the other angles, which in this case we do know that alpha is 11 degrees, then we can simply subtract 11 from 90, and now we know that beta angle is 79 degrees. Let's go ahead and plug that into our visual, our triangle. Now we need to find the lengths of the sides A and B. And to do this, we will use our trig functions. You should know these trig functions at this point, but I've written them down very quickly. And in this case, we're going to be using trig functions for alpha and beta. But the trig functions, of course, are sine, cosine, tangent over opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Now, for this purpose, I'm going to use sine, and basically, as long as you know the numbers that you should plug into these trig functions, you can pick whichever one you like. And like I said, I'm going to use sine. So first of all, we're going to find the sine of alpha, which is A. We're looking for A, so we're going to use the sine of alpha, which is the opposite of A. So sine of alpha is opposite over hypotenuse. And then I'm just going to insert what I know. So I know sine of alpha is 11 equals, and on this side I only know the hypotenuse, so I'm going to put that in, 24, and of course we're looking for A. Now, in order to solve for A, we must multiply both sides by 24. So now we have 24 times sine 11 degrees equals A over 24 times 24. And on the right hand side of our equation, 24 will cancel out, which leaves A. And now we have 24 sine 11. Now, at this point, you just take your calculator, plug in the information that you know, and you will find A. And be sure that your calculator is set to solve for degrees, because that is what we're working with. And when you plug this in to your calculator, 24 sine 11 degrees, A will equal 4.6. And 4.6 is rounded to the tenths place or 1 decimal place. So now we can go back up here to our visual. A equals 4.6. So we knew alpha angle, we knew 90 degrees, we found 79 degrees equals beta. We knew that the hypotenuse, or C, was 24. We found A. So the only thing left to solve for our right triangle is B. And to find B, I'm going to use the sine function again. This time we're solving for B. So we're going to use sine of beta over, opposite over hypotenuse. And inserting what we know. Sine of beta, of course, is 79 degrees. And this time we don't know B. And again, we do know that the hypotenuse is 24. One more time, we're going to multiply both sides by 24. 24 times sine 79 equals B over 24 times 24. On the right hand side, 24 cancels out, which leaves us with B. 24 sine 79 on the left hand side. And once again, plugging that into your calculator, you will find that after you plug all your information in and round to the nearest tenth or 1 decimal place, whichever one you want to call it, your answer is 23.6. And so now we know that B equals 23.6.